Alright, so how did this question go? You got a circle with AB less shorter than AC. That is not it. And then you want the angle bisector of A meets the circumcircle at like D.
Wow.
Wait, Johnny inversion point again?
Oh my god.
Yep. And then the okay, how do we draw this? The external angle bisector of A.
Okay, so the tangent basically
No. Meets the perpendicular bisector of AC at Z.
Oh damn.
Z. Alright, and then let M be the midpoint of AB. And then it asks you to prove that
I had to read some stuff you wrote.
AMDZ cyclic.
What?
Oh yeah, this question, yeah.
MDZ.
Oh no, the bashed question.
AMDZ.
Interesting.
Yep. Alright, so what we do here is, let's see, how do we think to do this, right? So this is alpha. We just can draw in this because it's like nice. Yep.
It's not the sheets from Broken Bay.
20 minus alpha. This is alpha. And this things are kind of weird, but it's like, and then you notice this is 90, right? And then you're like, okay, that's nice. How do we use this? Right. Okay, we're gonna. So it would be nice to show that this thing. Use bow tie to show that this thing. We want to show that this thing might be 90 degrees as well, right? Okay, so 90 degrees. So then, if we look at this diagram, we're like, okay, 90 degrees. That's kind of been our diagram a few times. If we try to use bow tie again, right? Like just this angle. Okay, we're gonna use a different. This angle alpha.
Oh yeah, that's alpha.
And then that might like MZD. If we do this, right?
Meant to be alpha.
So that's also meant to be alpha, right?
Yes.
Big pi thing. And in the same way, we want to show this is 90 degrees. We want to show that's alpha. And you're like, wait, that kind of looks like that's like similar to this triangle over here, right? And so we're trying to show that those two are similar. So
wait.
TP. It is exactly a similar switch. That's why we picked this one instead of the other one.
Well, I'm confused. Wait, which?
Hang on.
The yellow one.
How could this not have been seen?
Yes, reason disbelief.
I mean, it took me so long to see this 90-degree thing that like, and then after that, this just.
Wait, what? How did?
How did you fail this? Wait, this is a 90-degree thing where you saw this.
No.
Saw the hard.
Like
stuff.
like.
He saw the hard stuff immediately, and
I didn't see. It took me a while to see this 90. Like this should be 90, but after I saw that, I just got it. But then, yeah. So for Alex, so we want this to be 90 because bow tie. We want this one to also to be alpha because bow tie. So then we want this one to be similar to this other one here. Which means, and then we can do some, now we can apply our similar switch shenanigans. We don't need this anymore, we don't need this. Yeah. Bro, alright.
Wait.
Nice, okay. So now we can try to do the similar switch tactic.
Switch keys to similar switch.
Oh,
Okay.
why?
Oh my
Ayya.
Alright, cool.
Strategically undoing his progress.
Yes, alright, cool. So ZM, okay, we'll call this N, I guess. So ZMD and ZNC. So now you want ZMN similar to ZDC. All right.
We're gonna do a little switch.
All right. So now what we got to do is we're gonna look for the really obvious angle. There is one really obvious angle. So yeah, we just do this. So we do this, and this is just alpha, right? This is alpha.
Yeah.
And then if we, this is 90 plus, so that would be 90 plus alpha. And then if we look here, this is 90 minus alpha. This, we don't call that, we don't call that alpha, no, beta.
Yeah.
And then this is
beta.
Yeah, this is beta, and this is alpha.
Alpha. Oh.
So this, okay, we have this angle. So angle
Johnny and
ZCD equals angle ZNM. All right. So generally in these questions, once you get something like this, you need a ratio. You're not gonna get another angle.
Nice.
But luckily for us, angles are very like ratios are very easy. So we want
Oh wait.
MN.
Sine 90
Yes.
minus alpha.
Okay, so we have, let's see, which ratios do we want? So we want ZN.
That's half of that.
Yeah. Yes,
Oh,
I think he's got it.
Okay.
ZN on ZC is
Oh
equal
my
to,
god, this is so massive.
this is equal to ZN on ZC is equal to like
Oh.
cos alpha, I think.
Okay.
Cos alpha. So we want MN on DC is equal to cos alpha, but you realize MN is actually half of DC. So if we're just drawing this is actually like, I don't know, this is MN
Oh my god.
ZX, right? And that's
No way.
the XC is equal to MN. So XC on MN is equal to M is XC on CD is equal to MN on CD is equal to cos alpha. So now you have these two on the same ratio. By similar switch, you're done.
Oh my god. Oh.
Wait, I don't get
This
the
question
second
is so
part.
big, bro.
So what?
Oh my god.
I don't see the
Let me just
second
go
part.
chill in the corner while
Which second
I
part?
soak in the
X. Wait, hold on.
So this thing is like, this thing's alpha.
Oh.
Wait, XC on CD equals M.
So X, so this is X. So XC is half of BC, and then MN is also half of BC.
Wait, hold on.
Oh no, I'm so blind.
I'm so blind. It's because you refuse to embrace the way of the trick.
Wait, is that done?
Yeah.
Yes.
Excellent.
Oh.
Any questions, people?
Questions, queries. Wait, that was pretty quick.
Yeah, speedrun.
Now time for nomic projections.
Wait, that was, what was that, 2000 and...
17, question 2.
Yeah. It's the one that we bashed a few different ways, eh?
Yeah.
No,
Yeah,
adding to
well,
the adding
well,
trick
I
back to
think
the
it-
collection.
We finally got
This
this.
is trick though.
Oh,
Trig bash.
Fine, actually, okay, this triangle is similar to that triangle.
Oh yes.
Wait, what is this?
maybe you have... Oh, wait. Maybe it was to another question. I don't know. There's a bunch of questions.
Wait,
Alright.
wait.
Shall we... Okay, thanks. Shall we
Go to the next one.
go to the next one? So stop recording
Some
and
garden gnome projections.